Now, starting topic 1 of Unit 2, again, you are to include these in your homework log. Let's go on to studying ratios, proportions, and variations. So, for number 1, determine the ratio and write it in lowest terms. Now, we said a ratio is comparison of numbers. We could write it as a fraction, or we can write it as horizontally using colons here. And the key to ratios, as you recall from our flipped classroom video lesson, is to be sure they are in the same units. So we would set this up 20 to 70, and then you have to simplify the fraction. So here, since there's zeros, we can just cross those off. And our answer then is 2/7. And they want it as a fraction. So starting off relatively easy. Now for number 2, again, we're going to set up a fraction. Our inches are on top. So 156. But now our bottom is feet. So we would have to change that to 12 feet times 12 inches in a foot. So this then becomes 156 over 144. And let's see what you can do to reduce that to lowest terms. So something like this, you can take a 12 out of each of these, and this would be the improper fraction. All right, let's go on. Now for number 3, and you're going to take a moment to write these in your notes. You can just write what I have in red. You see a number of products of the same thing, but in different sizes. So how do you figure out what each ounce would cost? Well, you take the total cost and divide it by the number of ounces. And then you're looking for the best price. So take a moment or more and do this calculation. Let's see what you get. Now, once you figure out the cost per ounce, you then compare and see that this value, which would be this one, that is the 36 ounce, would be the best buy. Now, often that is, but sometimes they figure these out. You realize that, I'm not trying to trick you or anything, but maybe a smaller purchase, depending on the bottle or the advertisement for that product or the specials, might be the better buy. All right. A little review on proportions is when you have two fractions. This is, for example, 4. We had said in the general form A over B equals C over D that we can cross multiply. A times D gives you AD, and B times C gives you BC. Now the A and the D, you recall from our flipped classroom lesson, are said to be the extremes, while B and C were said to be the means. And we said the expression, the product, that is multiplying, of the extremes equals the product of the means. That's what is illustrated here. So as we do this cross multiplication, we get 32n equals 8 times 12 is 96. And now to solve what n is, we divide by the coefficient, that is the number that's with the n. And you're going to get n equals what? 3. So what is n here? In your homework as you do it, you would put a 3 there. And this is the work you would show to support your answer. Again, if you have a question, be sure you're asking. Now, for number 5, we're setting up a proportion that a physician orders this much of a drug, and it's available in this milligram tablets. So how many of these tablets must be given so that you can get this much of a drug? So take a moment, see what you can figure out, and we'll come back. Now, setting it up as a ratio or proportion would look like this, but in a sense, all you had to do was take the amount of prescription needed divided by what's in each tablet, or if you cross multiply, you would get that n, 17.75n equals 5.5, and you're just dividing both sides by this. And then n equals 2. All right, I may be making this more complicated than it should be. Again, reading it, and the simplest way is just take this and divide it by this, and you get 2. All right. Now, in example 6, want to do a survey. Fella goes out, catches 250 trout, tags them, throws them all back in. Then they mix up with the lake's population. Then at a later time catches 160 trout. And note that 4 of them are tagged. So he's wondering how many fish are in the lake based on this sampling. Well, if he gets 4 out of 160 that he caught that were tagged, and the other time he had tagged 250 out of X, this would be, in a sense, a proportion which we can use to sample our fish population. So what will you do here? Well, you're going to cross multiply, get 4x, and we'll use the x here. And then we're going to multiply this and then later divide by 4. And let's see what you get. So Cross multiply 4x, cross multiply 40,000. Divide both sides by 4. We get our fish population is about 10,000. Again, this is often used in field studies. Now, as we look at number 7, it says here a force is required to compress a spring varies directly to the change of the length. Okay. So we had said in our flipped classroom lesson that anytime you hear that something is a direct variation, you are to write that direct variation equation. Y equals kx. You could add this as extra notes here. Now, this is the general form. We mentioned too that you should try to make the letters specific to the example. So here we have a force, which we'll call F, replacing the Y, is directly proportional to its length, X, which we will call L, and our constant of variation. So the first thing is, if we have a force of 14, which we'll put here, it requires a certain length of 7. So we replace the length with 7. Now we want to solve for our constant of variation, which is k. So we're going to divide both sides by 7 here. And we get k equals 2. We then write our equation of direct variation. Force equals replacing the k with the 2, and then our L. Now, it's asking how much force is required to compress the spring to 8 inches. So all we do here is put F equals 2 now, our constant of variation, times 8. And we get our force will be 16. And that's what we put for our answer. So this one's important for all of your homework, that if we find that our example deals with direct variation, we write this formula. Then we look more closely at the information they're giving. We may change the letters. Then we substitute into the formula the items for F and L to solve for the letter K. We then do that. Then we write our equation of direct variation, substitute in our new value to find the answer. So there is a protocol, and this is what we mentioned in our other lesson. Now, for this example, take a moment to read it carefully, and then you're going to set up some sort of proportion, and let's see what you get. Now, did you get something like this? So this is the number of euros to dollars. So 1 euro to what it's worth in dollars. So you want this many euros. How many dollars? Which you'd actually put an X there, but I thought I'd fancy it up a little. So you cross multiply, and it's just this is 1 euro here, and you're going to need this many dollars rounded to the nearest cent. So this is quite a rate. Today it's not quite that. It's Usually more than $1, but not $1.50 as it looks here. My daughter lives in Europe, so we do an exchange every once in a while. Now, for number 9, again, as you read your statement, we're talking about the distance a body falls varies directly. So again, that brings up this formula, y equals kx. But now you're saying the distance, k, is the square of the time. So we're changing the x to t and squaring it. So what we want to find out then is what would our k value be? Well, we know our initial distance is 128. We don't know what k is, but it hits the ground in 4 seconds. So we know our t is 4 that we have to square. So this becomes 128 times 4 squared is 16k. So we're going to divide both sides by 16. And we get that k is 8. So our new formula of variation will be distance, d, equals our new value for k, 8, and then t squared. So now they're wondering how far did it fall in the first 3 seconds. So take a moment, put that in there and see what you get. So this is going to be 8. T is 3 squared. This is 9. So 8 times 9 is 72 feet. Okay, not too bad, but again, take some good notes. This will be your protocol for solving this kind of example. All right, for our last example, number 10, again, they're saying it's direct variation, but joint direct variation. So we're saying the weight of a fish is equal to k, which is the constant of variation, times the girth, which is around the body of the fish, times the length of the fish squared. So this is the formula we're going to use. Now we should mention if it was inverse variation, that formula would have been y equals k over x. I see we're not picking one of those up, but you will get some like this, and it's done in a similar way. And we do show that in our flipped classroom video. So take a moment and see if you can just substitute and solve for the letter K here. Now, this one's a little tricky as you do your division here, because when we square this and multiply it by 20, we get this big number that we're going to divide both sides by. So 21.2 divided by this, in your calculator they give you something that looks like this. Now this is in scientific notation where they say instead of putting a 10 here they put a capital E. So let's just change that E to a negative 10 to the negative 4 power. Well, what does that mean? Well, that means from this particular place, there's going to be 4 decimal places. So I have to add some zeros here to get what my number would be. So I need 4 places. So I have 1 there. I had 3 zeros. I move this over. And now my K value, if I'm going to round it here, make that a 7, I get 0.00087. Or if you have the ability to leave this number in your calculator, just use that as K. That's what I'm going to do. So now you're going to put in here, you have your K value in your calculator. You're going to put in your new girth, which is 18, and your new length, which is 39, that you're going to square, and just put that in your calculator and you should get a nice answer there. Let's see what you get. So when I do it, I get 23.69. Now they're asking you to round to the nearest tenth. So I have a 9 here. I'm going to drop the 9, add 1 to the 6. So my final answer for this is 23.7 pounds, which is what they're saying we put into our software. Okay, again, there are going to be others. If you have questions, be sure you're asking. I do have this slide that we would normally show just to give you a thumbs up here. When we are in lab, bring your questions into MathLab to get help before or after our open notes quizzes. Okay.